This is actually a really interesting problem, okay? It's got a diagram given to you, okay? And it's about a rectangle, and you have so a point is you have a rectangle ABCD, right? And then you define a point on K on the side CD, yeah?
Yes.
And you draw this like line, okay? And then you draw the perpendicular from B to the AK, yeah? Right? And then once you got that, you draw the in circle of this triangle, and then you draw the in circle of this triangle, and then you draw the in circle of this quad, okay? Does that make sense?
Yup.
Okay, so the in circles of quads might not even exist, okay? But it's kind of claiming it exists. Okay. And then it's saying if the two circles in gray, like the whiter circles, yeah? If they're of equal size, then the dark circle is also of the same size. That makes sense? Okay, let me give you actually this was a solution. Let me give you a solution and you tell me if the solution is correct or not. Okay? Make sense? Okay.
Okay.
So let's assume the triangles of the same size, the circles of the same size, yeah? So this one, this circle, and this circle are the same size, yeah? Okay. If they're the circles of the same size, then the circles and all of the setup here are reflections about this midline of A, B, and CD, okay?
How do you prove that?
Shh. You're not to contribute to this yet.
Oh, okay.
Yes, Henry.
Okay, so we're saying that the whole setup is symmetric about this midline, yeah? Okay? Because the circles are the same. Okay. So that means this line reflects to this line, okay? Right? And what that means is that this triangle is not only a right angle triangle, but it's actually an isosceles triangle, okay? Which makes that 45, okay? So this is in fact an angle bisector, okay? And then this side here has so this triangle here also has 90 degrees, yeah? Okay? And it also has 45 here, okay? So that means the other one must also be 45, okay? Okay. So the red triangle and the blue triangle are similar, right? Yes? Okay? And if they're in circles of the same size, they would have to be congruent. That makes sense? So not only are they the same angles, they also have the same lengths. That makes sense? So it suffices to prove that the triangles are congruent. Does that make sense?
Yes.
Okay, now I'm going to prove the triangles are congruent. So now, okay, so if you have comments, wait till the very end, okay? It's not a very long argument. So basically, by symmetry, this point here is the midpoint, right? Well, we know this point is the midpoint, yeah?
Yeah.
And that's also where the circle touches, yeah? Right? So the circle is tangent at the midpoint here. Does that make sense? Okay. So if the circle is tangent at the midpoint, that means this length here is half this whole length here, right? Yeah? That makes sense? And we're trying to prove that this purple length is the same as this length here, right? Because then they'd be congruent. Does that make sense?
Yeah.
Okay. But this length here is equal to this length here, right? Because they're tangents on a circle. The tangents are equal, yeah? Okay. And then, but because this is also isosceles, this is also the midpoint of this. Okay? Does that make sense? Because this is an isosceles triangle, right? So by symmetry, the inner circle is going to touch at the midpoint. Yeah? Okay. And so that means this length is half of this length, right? So basically, these two lengths are the same. Yeah? So this length is the same as this length. And so then these two triangles are congruent with that. Does that make sense?
Can I
Okay.
question something?
Unless if it spoils, then no.
I believe it's not spoils.
Okay.
But like it's okay, I shouldn't say that.
Okay. So this is a question for like, you know, Ryan, Daniel, Andy, Richard, Lucas. Wait, unless Lucas has seen this. I don't think Lucas has seen this.
Michael.
And Michael, yeah.
What?
Is this a correct solution?
Okay, I think I should say that.
It hinges on the fact that
Michael.
What?
Okay, I think I should say that.
Say what?
From your perspective, that's from your perspective, why this is equal to this?
说我给那个老头老太太的那个女儿发的消息，大概4点半给他发的。那现在我可以看他读了我的消息，人家不回我，他什么意思？他不想说。
I explained it's the midpoint.
Oh, midpoint.
你也不用，人家可能。
I'm saying this is the midpoint. This is the midpoint. And these are equal.
Yeah.
And the whole thing is
Oh yeah, because it's 45 midpoint. Okay.
Do people understand the argument?
Yeah.
Okay, so now the question is the argument correct? Yeah?
Why does the midpoint contact the circle?
What do you mean, why does the midpoint contact the circle? So like, if you have an isosceles triangle, right? Like this, the inner circle is it's symmetric, right? So it should touch at the midpoint.
What about KDA, ADK, you know?
Alright, what?
Doesn't this hinge on the fact that like it's symmetrical?
So like if you recall what I said, okay? So the first step of the argument was this is symmetrical, right?
Yeah.
The second part of the argument said that this length equals this length, yeah?
Yeah.
Okay, so if it makes it easier for you, there's only two parts, okay? So if both parts are correct, then the proof is correct, okay? So you can even ask the question like, is the first part correct? Is the second part correct? Yeah, it's like you could actually turn it into two questions. Does anyone want to dare say an answer? Is the argument correct?
Yesn't.
Huh?
Yesn't.
Yesn't. Yes, it's not.
Very helpful.
Yes, since it means unsure.
Yeah.
Maybe not our reply.
So actually, it's very difficult. It's very difficult to be balanced in these kind of situations. You understand? So it's like a lot of the time the context does give it away. I mean, if you were to just venture a guess, would you say it's correct or incorrect?
Incorrect purely because of the
Incorrect.
way you're speaking.
Yeah.
Well, let's think about it this way. The lesson is kind of meant to be like we're going to try to find a solution to this problem, right? So if that was the correct solution, then that would kind of like invalidate the exercise. And also, I think also it sounds like it's correct, right?
He's using
Yeah.
reverse psychology.
So that's where the lesson really is, okay? So maybe you can, if you haven't decided if it's correct or not, then how about this? I'll tell you that it's incorrect, yeah? You can tell me where it went wrong, yeah? But sometimes like something can be incorrect, doesn't mean it's false. Does that make sense? So the triangles are still congruent, yeah?
Yeah.
And like it could still be like a reflection. It could be, all these things could be true, but the argument could be incorrect in the sense that like you're not proving that they're true. You're kind of just like, you're skipping a step, you know what I mean? Like for example, if I just said, oh, because the two circles equal, the third one's equal. Is this argument correct?
No.
Well, the statement's true, right?
Yeah.
But there's no argument there, you understand?
Yeah.
So,
Yeah, so I think there's a part that's incorrect and it's based on a mistake, okay? Which is kind of obvious. Even though, like, the mistake could be... But you were here, so you should probably not spoil.
Starting to remember some stuff.
Okay. Alright, I'll give people 8 minutes to figure it out, okay? I'll just pause it here. Alright, so you've had a bit of time, so if you look back to what I said, okay? I said two things, yeah? I said that this was like a line of symmetry, yeah?
yeah.
Okay. So I didn't actually prove that this was a line of symmetry, do you understand? Okay. So the question is it actually a line of symmetry or isn't it? Does that make sense? Okay. And then I said, I haven't told you the answer yet, okay?
Yeah.
And then I said, well, this is the midpoint, and then this is the midpoint, and so this length is equal to that length, so they're congruent, right?
Yeah.
So I did more than just claim stuff. I actually tried to prove it, right? Does that make sense? So in one of them, the context is different than the other one, yeah?
Yeah.
So for the first part to be wrong, the claim would have to be wrong.
Yes.
Does that make sense? Because it wasn't proved,
Yeah.
okay? So maybe the first question is it true that it's a line of symmetry?
Is it?
Is it? Yeah, so I think we would have to try to prove it, right?
Yes.
So given without proof, it might not be complete, but I think it actually is true, okay? So that's not the main issue, okay? Okay, so the main issue, and some people, actually a lot of people did this, okay? So everyone has some experience with this. The main issue is we're assuming that the circles touch at the same point.
Yes, that's why my solution doesn't work.
Yeah? You understand? Like, the circles probably do touch at the same point, yeah?
Prove it.
But you can't assume it, yeah? Actually, I had someone ask me in the exam, do the circles touch at the same point?
Yeah.
And I'm like, the question isn't asking you to assume the circles touch at the same point, yeah? But you might prove that the circles touch at the same point. That's different, right?
Yes, it is different.
So it's kind of weird that they asked me that, right? But at the same time, it looks like they touch at the same point, right? Yes? And if the circles were congruent, yeah? If the triangles were congruent, then they would have to touch at the same point, right? Does that make sense? But you can't assume it, yeah? Do you guys understand what I'm saying? Because we went, this point here is the midpoint, right? Yeah? So this length here is equal to this length, yeah? Right? But that length is touching the black circle.
Yeah, is it touching
Yeah.
the white circle?
But we don't know where it's touching the black circle. We just assume to touch the white circle at the same point, and then that's the midpoint of this, right?
Who says so?
But that's not a correct argument. Do you understand? So it's obviously a little bit hard to say something's an incorrect argument when all the statements are true. Okay? But you can understand how, like, that's a mistake to assume it's the same point to conclude that. Does everyone understand? Everyone understand? You understand? Lucas, do you understand?
Yes.
Okay, so that's kind of one of the reasons you have proof, right? Like, see, a lot of the most common experience is people say, oh, they come out of an 8-question exam, oh, I solved all 8 problems, and then they come out and their score is like less than like 2 problems worth, because they're thinking they solved them, right? So actually, if you're missing that one thing, and that was your entire proof, you might only get 1 out of 5, yeah.
Yeah.
But you, in your mind, think you got 5 out of 5, right?
Yeah.
Does that make sense? So, yeah, so it's not good to just kind of do each problem like that, you know what I'm saying? You're trying to do one problem perfectly, yeah? You're not trying to do 5 problems superficially, okay? Yeah, you just do like a little bit, like as face value or something, you know? Alright, so maybe the next exercise,